In these notes, it says system of equation substitution. So the learning target is I can solve a system of equations by using graphing, elimination, or substitution. Since we're talking about substitution, you want to think of like a substitute teacher. When your teacher is absent, a substitute replaces that teacher. Both teachers are not in the classroom. It's just one goes in and one comes out. Same thing with the substitution method. Now, one solution is the same as the other two methods, graphing and elimination. When you get one solution, you're going to get x comma y. When you show your work and you get the equation that has no x or no y, and you get a false statement, that is when it's no solution. So you will get like 0 equals 12 or -1 equals 9. Now, if you get a different false statement than, let's say, your desk partner, that's okay. A false statement means no solution. It means they probably just showed their work slightly different than you did, but the answer is still the same, which is no solution. Now, infinitely many solutions is just the opposite of that. You would get a true statement. So something like 0 equals 0 or -4 equals -4. Something that signifies one number on the left is the same as the number on the right. Now there are 3 easy steps. First, you want to make sure that the variable is isolated. Please recall that isolated means by itself. So in this case, it could be an x equals a number, or y equals a number, or x equals several terms, y equals several terms. Whatever it is equal to, that is what you're going to substitute in. Once you do that, I recommend having some type of strategy, like a highlighter or a colored pencil, something for you to circle all of those terms with, so you make sure that you input all of those into the correct variable. And then lastly, once you substitute the portion, you're going to solve it. It's going to probably become a multi-step equation. And then once you're done with that, you're going to plug it back into the first equation that you dealt with. Now, example 1 is where IXL starts off, and it's actually one of the easiest ones because we have a variable that's isolated, and in this case, it's y. There's nothing on the left with y. It's a 1y. There's no number. There's no other term. It's just y. Now, whenever you have a variable isolated, you want to go to the second equation and look for that exact variable. I recommend highlighting it. Now, it says in step 2 to circle or highlight everything after the equal sign. So I'm going to circle that 3, and then I'm going to draw an arrow down to that y. That is what you're going to substitute in. Now, I'm not going to do anything with the first equation. I'm just going to rewrite the second equation. But instead of that highlighted y, it's going to become a 3. And then you just substitute it. 6 times 3 is 18. And drop down everything else, and now it's just a 2-step. I ran out of room, so I'm just going to write it up here. 2x equals -4. Divide by 2. You're going to get x equals -2. Now what you usually do, you're going to plug that back into an equation. However, in this case, we already have y equals a number, so that's actually going to be our y. So then we have -2, 3. Since we got an ordered pair, it's one solution. Make sure that you write in complete sentences. Capital letter in the front, period at the end. Make sure that you spell each word correctly. Now, notice for your turn, it's not necessarily y always. Y is the most common, but x can be isolated as well. Notice that x is on the left of the equal sign. There's nothing with it, no number, no other term, and it equals 4. So what I recommend doing is going to the first equation and highlighting the x. One of the most common errors I see, one of the most common mistakes, students substitute into the wrong letter or the wrong variable. So then this 4 is going to replace the x. So then we have -3 parentheses 4 plus 2y equals -6. And now just simplify. 6 plus 12 is 18. Divide by 2. We're going to get y equals 9. And we already have x equals a number. So then x comma y, the answer is going to be 4 comma 9. And once again, you're going to have a one solution because it's an ordered pair of 4 comma 9. So you can write that as your sentence. Now, example 2 is where it gets harder. You still want to look, and if once it gets hard like this, if you need to draw your line just slightly, we're not going to solve anything. We're not going to move any variables yet. Just for you to see, for example, we have the x by itself, but the 3y plus 2 is not by itself. So the x in this case is by itself. So we're going to want to substitute everything on the right, even if it's two different terms. All of that, the 3y plus 2, can be replaced in the x. Now, you're going to just write the 2 because that's on the outside. And then instead of the x, you're replacing it with what it equals. In this case, it's a 3y plus 2. Now notice in black, I wrote the -6y and the equals 4. Now you just distribute. Got the 6y, you got the plus 4, take away 6y equals 4. Now, just like in our SLAT unit of solving equations, you just combine like terms. We got the 6y minus 6y. That actually goes away, and you're left with 4 equals 4. Now, if you looked up here, infinitely many solutions would be a true statement. Now, remember, when you're checking with your desk partner, they could have a different true statement. They could have 0 equals 0, and that would still be the correct answer. So it's infinitely many solutions because I got a true statement. Now you want to look over here. I have a y by itself. I have a y equals. In this case, this y equals 2 items. It equals the -3x plus the 4. So those are 2 different terms. I recommend going to the next equation, the one that you're not dealing with, and highlight that y. And that is where the red bubble is going to go. So we're not going to do anything to the 6x or the plus 2. We're replacing the blue y, with what we wrote in red. Now when you distribute, you do nothing with the 6x. It's just the 2. So 2 times -3 is -6. 2 times 4 is a positive 8. When you combine like terms, goes away. You're left with 8 equals 8. So once again, it's infinitely many solutions. Because I got a true statement. Now, example 2 was pretty difficult because you had more than one term to substitute in. Example 3 is probably one of the hardest problems I can give you, because if you notice example 3, there is no isolated variable. It looks like the y is by itself, but if you go a little bit closer and see, you still have that 3x with it. Now, the y looks like it's isolated because it has a coefficient of 1, and that's actually what we want eventually. But right now, our main concern is to undo that 3x to truly get the y by itself, because right now it's not. It's on the left-hand side with a 3x. So in our slot unit, we learned we can move anything over the equal sign by undoing, by doing the inverse operation. So the inverse operation of adding is subtracting. So now we can officially have that y isolated by itself. Now please note that the 4 and the negative 3x are not like terms. One has an x, one does not. So I recommend just rewriting it. Now we have something that we can deal with. Don't go back to that original equation that you changed. Go to the second equation and highlight that y. That is what you're going to plug in. And now it becomes a problem like number 2. So we have 6x plus 2, negative 3x plus 4 equals negative 2. And now, just like example 2 in your turn 2, we're going to distribute. That 6x, nothing happens to. Then we have negative 6x plus 8, because I distributed, equals negative 2. That goes away. We're left with x equals negative 2, which can't happen. That's a false statement. So a false statement means actually no solution. So there is no solution. Because I got a false statement. Same thing with your turn 3. You want to look at the variables. This variable has a 6 with it. This has a negative 2. So really the first equation isn't a good one to deal with. This one has a negative 3, but wow, jackpot. We got one that has a coefficient of 1. So we are going to change the second equation. So just like example 3, draw that little line to undo negative 3x. We add 3x to both sides. So then officially, finally, we can get that y isolated. Circle what it's equal to. Highlight the other y. And that's what you're going to substitute in. Now, once you circle the two terms, I recommend just rewriting the first equation. So we have the 6x minus 2 parentheses 3x minus 4 equals 4. Once again, drop down the 6x and then just distribute. So then we have negative 6x plus 8 equals 4. The 6x's go away. We're left with 8 equals 4, which cannot happen. So once again, it's no solution. because I got a false statement.